Good morning to all. So in this class, we are going to discuss about speed control of induction motor. The stator and the rotor speed can be calculated using this slip equation. So basically, the slip which will define the relation between your stator and the rotor speed. So based on above the formula, Ns is nothing but 120 F by P and Nr is nothing but 120 F by P into 1 minus S. Okay. So these two equations will give the proper definition of speed for the calculation. So the speed control can be classified into many types. So the speed control is the necessary required for many applications. Okay, so we have to control the speed for the application purpose only, not the general purpose. Then the machine manufacturers does not decide the speed changes. So they are manufacturing the machine for the rated speed, rated rating only. For example, the machine having 3 kilowatt, 5 HP, then 1500 RPM or 3000 RPM, and the 440 volt or 220 volt, so whatever may be. So these are the standard specifications we have for machine manufacturing industry. So then after that, requirement of our application, we are going to changing the speed by doing any special control technique. So here we are having a pole changing methods. So we are going to change the pole. So we have 4-pole machine. For the application purpose, we are going to change by 2 by changing the connection of the winding. Okay, and also stator voltage control method. Stator voltage control, the voltage is directly proportional to the current and the speed of the machine. So when we are changing the stator voltage, definitely the machine speed will be changing. But so this method normally not give the efficient. Then supply frequency control. By changing the frequency also one of the parameter to changing the speed of the machine. Okay, we can do this. A rotor resistance control. By inserting a rotor resistance in the machine, by that way we are varying the rotor current so that we can change in the machine. Then finally slip energy recovery. So due to the slip changes, we can do this speed control. Okay. So pole changing method. So in the pole changing method, we are having 3 types. One is multiple stator winding, method of consequent of poles, pole amplitude modulation. So these are the 3 techniques we have. So in very basics, the pole changing method is not frequently used in any industries. This is a time-consuming process for manufacturing the machine and also the labor cost. So in the multiple stator winding method, the 2 windings are provided on stator, which are wound on the 2 different number of poles. One winding is energized at one time only. So let us consider the motor has 2 windings for 6-pole and 4-pole. Okay. So for the frequency of 50 Hz, we are applying this. When the speed of the machine is about, for 6-pole it is 1000 RPM and 4-pole we are having 1500 RPM. Okay, so very basic formula Ns is equal to 120 by P. So this method is less efficient and more costly. So already I told that. So there is only 2 possible speed we can do this calculation. Either we can run the machine by 1000 rpm or 1500 rpm. So in between we cannot changes any speed in this machine. So method of consequent. In this method, a single stator winding is divided into few coil groups. So we are going to divide the number of coil groups in the stator winding. So the terminal of all these groups are brought out. Then simply changing the coil connection, the number of poles can be changed. Okay. So each and for example, the stator coil groups taken out into 4 groups. Okay. So where we are giving supply, so that particular coil energy AC. Okay. So that coil produces the necessary flux, then that will give the desired speed. Otherwise, we can go to the series and parallel operation of the machine. So we are dividing the coil into the different groups. So by that way, we are going to create the some of the winding in series and some of the winding in parallel. So this series and parallel combinations will give the changes in the speed of the machine. Okay. So this will be represented here. So here we are splitting the machine by 4 coil groups A, B, C, D, or 1, 2, 3, 4. Okay, so these 4 groups are splitted and creating in a series and parallel combination connection. So this will create the changes in the speed of the machine. So stator voltage control. So already we know very well about this stator voltage. So when we are reducing the supply voltage, we are having reduced machine speed. So we can experience in our home itself. So we are having the fan. We are using the regulator of. So regulator is the better example for the stator voltage control. So when you are changing the regulator, which means the voltage is changed from 0 volt to maximum volt. Okay, so we are going to changing the position from 0 to 1. So some resistance were applied to the before the machine. So through this, maximum voltages will get dropped and the minimum voltages only go to the fan. So like this, we are going to varying the voltage and the corresponding speed will be changing. So it is suitable application where the load torque decreases the speed. So see this picture, torque versus speed. So the machine speed is initially very minimum, the torque is very maximum. When your machine is ideal, the torque is very maximum, then only the machine is starts moving. So now V1, V2 and V3 represents the torque about the machine. Okay, so your machine voltage is maximum, this V1 is maximum, your torque is maximum, your speed is maximum. Okay, so like this the curve will change accordingly. So the variable voltage for speed control for small size motors, mainly for single phase, can be obtained by the following methods given below. By connecting an external resistor in the stator circuit of the motor, by using auto transformer, by using thyristor voltage controller, by using triac controller. So these are the techniques we have to reduce the supply voltage of the motor. Variable frequency control. Okay, the frequency is the very major parameter to control the speed of the machine. So already we discussed NS is nothing but 120 F by P, and also we know the basic voltage expression of the machine. E1 is nothing but 4.44 kW1 F5 in T1. So the F represents the frequency, phi represents the flux in the machine, the T1 represents the number of turns in the machine. So if you are varying your frequency, your speed is very directly changing. So in order to minimize the losses, to avoid the saturation, the motor is operated at greater air gap flux. So this condition is obtained by varying the terminal voltage, the frequency, so as to maintain E by F ratio constant at the rated value. So this type of control is known as constant volt per Hertz. The variable frequency supply is obtained by the following converters. So we can go with a voltage source inverter, current source inverter, cycloconverter, a fixed voltage and fixed frequency AC to variable voltage and variable AC frequency. Okay, so these are the variable frequency drives are regularly used to changing the speed of the machine. Then this is the model of cycloconverter. Here we are using the 4 thyristor to changing the pulse. Then rotor resistance control. So it is possible to have a large starting torque, low starting current, and a large value of pull-out torque at a very small value of slip. So these are the wordings are very important. So by go with rotor resistance control, we can maintain a large starting torque, and also we are maintaining a small starting current. So the major disadvantage of this method are the efficiency is low because additional losses are present in the resistor connected in the rotor circuit. So where and all we are connecting an additional element to the system or the circuit, definitely which will prefer to reduce the efficiency of the entire system. It will take some energy to work on it and stop on it. So both the energies are wasted here, so that additional resistance including in the system will be definitely reduces the efficiency. So this efficiency is greatly reduced at low speed because of high value of slip. This method of speed control is used in crane, board-level drivers, and other intermittent load applications because of low cost and high torque capability at a lower speed. So this is the pictorial representation of your rotor resistance control. So we are having here stator, rotor, and so before entering this supply to the rotor, we are having slip ring and brushes. Then externally we are having external rheostat. Okay. So by varying this rheostat, you can varying this current and fluxes, so that we can reduce the speed of the machine. Okay. Thank you.